So let's attack a slightly more challenging problem. You'll notice in part B, we have 2 times matrix A, and we're subtracting off matrix B. Now, as long as your matrices have the same dimension, you could add and subtract by hand. And you're only allowed to add and subtract if they have the same dimension. So just kind of take a look at matrix B and also verify with me that it is 2 rows by 2 columns. So we also have a 2 by 2 matrix here. So if you don't have a calculator around, what we can do is multiply by hand. We could just say, well, there's a constant times matrix A. So we can take 2 and then write it out. So it really kind of depends on what class you're taking, depending if they allow calculators. I like to show both just in case. We are going to subtract off matrix B after we multiply 2 times A. So it's kind of like order of operations in a sense. So matrix B, the elements are 3, -8, 9, and 1. So first thing I will do is I will multiply the 2 to all of the elements in matrix A. So we are going to be looking at 2 times -4, which is -8. 2 times 10, which is +20. 2 times -12, which is -24. I'll show you that there. And 2 times 5, which is 10. So constant times a matrix. Now, I'll just write this out for purposes of explanation. So at this stage, because we are subtracting 2 matrices with the same dimension, they're both 2 by 2. Maybe I'll do that in green to verify that. Oh, never mind. You guys know what I'm talking about. So as long as we have the same dimensions, what we're going to do is all you have to do is subtract the corresponding elements. So basically, you combine everyone into another 2 by 2 matrix. And you'd be looking at the elements. So I'll do this by hand. I know we can actually do this mentally, but I like to demonstrate just by helping out with this. So I have -8 minus a 3. That's A sub 1, 1 and B sub 1, 1. 20 minus a -8. So A sub 1, 2 minus B sub 1, 2 in a sense. I know it's 2 times A sub 1, 2, but you guys know what I mean. We're subtracting corresponding elements. So I'll just do the highlighting to emphasize this so that you kind of see where I'm going. 20 and the 8. We are going to look at -24 minus 9. And you guessed it, we have 10 minus 1. I was going to color code that for you though. And I think we lost our color coding. So let me make sure we're making clear on this one. So let's do this with purple. So 10 minus 1. So now the only thing left to do is for you to simplify. So what do we want to do is, well, what is -8 minus 3? Well, that's going to leave us with -11. 20 minus a -8 is +28. And -24 minus 9, -33. And 10 minus 1 is 9. So that should be our result of 2A minus B. And that's all nice if you prefer to do it by hand or if you don't have a calculator. But like I said, we can go to our TI and enter everything in. So I'll take that liberty, switch on over, and just make sure we have the right matrices entered in. So we shall double check. We'll switch over to our TI. And if you remember, what's kind of cool about these problems is we already entered in matrix A from a previous example. So let's double check with matrix A. It's already a 2 by 2. If you want to check what it looks like, you could either call it up or edit it to see that it is in fact the same. -4, 10, -12, 5. Or let's quit out of that for a second. We could have called it up. Let me also go to edit. I want to enter in matrix B, so I can use this as well. So let me press enter. Matrix B is a 2 by 2. We're entering in the row and the column dimensions. And then matrix B will enter in the elements. So 3, -8, 9, and 1. So we've got this taken care of. I'm going to quit out of this. And now, if you'd like, you can now start calling the names. So what do we have? 2A minus B. So I'll say 2 times matrix A. So let's call that up. We can go second matrix or second X inverse. Call up the name of the matrix. So that's item number 1. Okay, we're going to subtract off matrix B. So let's call that up, second matrix one more time. We're going to do item number B. That's 2. So you have 2A minus B. Press enter. And let's see if we got the same thing we got by doing the computations by hand. So I'm going to copy that over so that we can do some comparisons. And let's go back and I'll paste it onto the side, hopefully. We'll paste. And let's see. Did we get the same thing? So what I'm looking at right now, just so that you all see, -11, 28, -33, and 9. And you're good to go. Now, if you'd like to do this over again with the TI, if you have a newer operating system, we can go back and talk about the matrix math just by entering the matrices into the calculator. So really quick, just so that you get used to it if you need to see it. Let's do this together. This kind of is nice if you are only doing the one single computation. But I kind of feel like it's a little easier so you don't have to keep entering matrices over again, but I'll show you. I like this previous way that I've done better. But let's do alpha zoom for a second. And before we do that, you would have to say 2 times. You would have to say alpha zoom, but then you have to enter your matrix all over again. So we can do that, -4. It's not too long, but I recommend if you're using these matrices for multiple computations, like you would be on a test or homework, I would recommend that you go through the other technique, second matrix or second inverse, to get yourself to enter everything in. So we have 2 times matrix A, just verifying that we have all the signs right and the elements right. We're going to subtract off matrix B. So again, we're going to have to name that. So we're going to say alpha zoom. It's also a 2 by 2 already highlighted. So we're already highlighted on the cursor. Okay, we can press enter. And then we'll enter in B elements. So we have 3, -8. I think I had a 1 there. And a 9. So let's press enter. And if you notice along with me, we do have the same answers. So feel free to use whatever feels better for you. I always like to show both ways at first, and then we take our favorite technique from there.